Hi, I'm DJ Ware. On this episode of the CyberGizmo, I'm going to be talking about namespaces, but more specifically, Linux namespaces, right after this. I want to do this one today mostly because one of my subscribers was very kind and gave me a link to the Windows subsystem for Linux on a more technical explanation of the differences between WSL 1 and 2, and I do appreciate that. But I thought it was kind of funny that one of the participants on the call referred to as Docker namespace as being old, outmoded, and old-fashioned. And so I was kind of laughing about that because Docker doesn't actually provide that namespace. It's provided by Linux. So that shot came across our bow. And so today I want to kind of talk about that a little bit and explain what Linux namespaces actually do. So that's why I wanted to do this today. So, let's take the Wikipedia definition. It's a good one. Namespaces in computing refers to a set of symbols or names that are used to identify and refer to objects of various kinds. So it's just basically a way to take things that are related and group them together and give it a name. So a namespace ensures that all of the given set of objects that have unique names so that they can be easily identified and referred to. So that's basically what a namespace is. We're done. See you later. No, there's much more than that. But namespaces is not anything new. And in fact, Microsoft, you have been using these namespaces ever since you published your first basic interpreter. And it goes back way before your company. And so it is fundamental to how programming languages and compilers are developed today, because the first instances of namespaces were used by programming languages to build variables that refer to memory locations. That way we didn't have to memorize those memory locations. We could just refer to it as a name. And later we were able to give it a type, and so that we knew that that memory location contained an integer or a string or a floating point or whatever. So yeah, they've been around a long time. So if you want to say that it's old and out-fashioned, great. What do you got to come up with that's going to replace it? So anyway, namespaces as applied to Linux were first used at Bell Labs in Plan 9. And of course, the very first one they implemented was the mount namespace. And oddly enough, that was the first one that Linux did as well. So the namespaces in Linux appeared in the 2.4.19 kernel. That was sometime around 2002. So we've had them around for a while in Linux, no doubt about it. But a namespace refers to a set of kernel. It's a feature of the kernel, all right? So, and it is used to partition kernel resources. So, in other words, I can take something that the kernel is providing and I can create a wall around it so that if I hand that off to a process, it can only see that view of the world. So it's kind of like a cheroot on steroids. In that I can affect everything about that application within the namespace definitions that I have available to me within the kernel. So a namespace consists of one or more processes plus a set of resources. So you can have a group of processes, you can have a group of users, you can have a group of resources within that space as well. And resources can exist in multiple namespaces. They don't get consumed, so that once you assign something to a namespace, it's not done. You can have as many assignments as you need for that same resource. Namespaces, however, are a fundamental aspect of containers in Linux. So let's talk about that. So why does Linux even need these? So the main purpose of it was to wrap some global resource in an abstraction being that kind of a layer that is a layer of definition. It's not a barrier. It's not a security barrier. It's just a way to refer to a larger group of things rather than have to list it. It's the memory, it's the CPU, it's the disk. that I can just refer to it as something, and then I don't have to, I can just use that something to isolate and give that process kind of a private view of those resources. So, and that effectively prevents that process from impacting another process that's running in a container, for example, on the same system, so that they do not inadvertently interact with one another. So the process has no idea it's running inside of a namespace. As far as it knows, it's got a private. It's running on the CPU, memory, and disks that are assigned to it. It just thinks that that's a processor. It just thinks that's a piece of hardware. So as of 5.6, the 5.6 version of the kernel, there are 8 different kinds of namespaces. I have not checked this under my current one, how many there are. I'll probably do that later today. And if I do find that there's a couple more that have been added, I'll let you know. But in 5.6, there are 8. And if you want to find out what namespaces that are being used currently in your system, you can just do an lsns command at the command line, and it will show you everything that's running. It'll show you the type of namespace. It'll show you the process ID that is assigned to it. It'll show you the process name that's assigned to it. And probably some other information that you can gain from that as well, but it'll give you a list. And what you probably will see in there is one or more of these: a control group, a C group, an inter-process communication, an IPC is how I think it appears on the list, a mount, which would be a file mount, and that would be the MNT command. Network, net will show up, process ID, time, maybe you might see time. User, definitely you'll see those. Unix time sharing, you might not see. UTS, that's we'll talk about all of these things in more detail, but there is one that was proposed at the time that 5.6 was released that didn't make it in, which was the syslog. It was proposed as a namespace. So let's talk a little bit about what they are. C group is probably the most complicated because it has direct impact on the containers themselves. It is used by containers to isolate a set of processes into a virtual system. Now, we're not talking about virtual machines here. This is software virtualization at the container level. And this was provided through the Linux kernel. This is not like KVM or any of the Type 1 hypervisors which do isolation at the hardware level. So this is not the same thing. There are containers that do include a virtualization piece, and those would be a hardware and a software version of the container, but we're not talking about those today. What we're talking about is containers like Docker and LXC. So C groups are kind of, a lot of people kind of, I've heard this, I don't know how many times I've heard this, they're kind of like Chroot, but they're not really like Chroot. Chroot, it was very good for its time, but all it really did was isolate your file system. So all it does is it moves the bar of where a process sees root beginning in the file tree. So I can move it to my home directory, and then that process that's running in my home directory thinks that my home directory is root, and it can only view anything under it. It's not allowed to see any of the file paths above my home directory. So effectively, that's all a chroot does. But as far as the process is concerned, it still sees a full view of the CPU, the memory, and any other IPC resources or network resources that are available to the machine. It still sees those. However, C groups allows me to limit, isolate, and measure resources on all of those things that I just mentioned. So it's much more than a chroot. They can have their own set of resource quotas. I can assign resource quotas to memory, to CPU, to network, and to the I/O. And I can also, indirectly then, I can also manage SLAs. I can also guarantee that particular, it's done by a subtraction, but I can also guarantee up to a point the SLAs for that particular resource as well. Inter-process communication namespaces, those are a more security-oriented namespace. This one came from Unix System 5 indirectly. It was turned into a namespace, but basically IPC is used to isolate inter-process communication. That is, I've got two processes I start up, and I want them to communicate with each other, but I don't want anything else to be able to listen in on that communication. And so I don't want it accidentally accessed, and I don't want it accidentally destroyed by another application as well. So unless those other applications have permission to use the IPC, you probably have, I don't know if anybody messes around with IPC too much anymore, but if you've done any IPC programming, you know that if you set one up and then you add an application to use it, the first thing that comes back if you forget to set the permission is, sorry, IPC communication denied. But each IPC has its own set of System 5 identifiers. It is a named communications channel, I guess, for no better word, but each of them has their own unique name. And each of them also has its own messaging queue, which is a file system that's built inside of it. So when I submit things that I want to communicate to the other process, I have a place where I can stack them up, and the other process can then just pull them off the queue as it has time to do that. And so that's basically what it is. That's what that's for. Mount Namespace is one of the oldest ones in Linux. That was the one that was first done. And that allows different views of the file system hierarchy. In other words, anytime I do a mount or a umount command, I'm managing the file hierarchy tree, right? So, and that is managing the mount namespace for that system. The mount namespace is used to create environments similar to chroot jails, and it is more secure than a chroot. It's quite different. I mean, with the mount space, I can create a different set of mount points for one group of applications from another. So they don't necessarily see the same mount point, and because the data is not mounted, they don't have a view to it. In the network namespace, that provides isolation of the system resources associated with networking. So each of the namespaces, this allows them to have their own network device, their own IP address, their own IP routing, their own port numbers, etc. So it provides additional features for containers by creating virtual network devices which are assigned to a specific container. And it is one of the ways that, if you've ever wondered how a Docker container can have a web server at port 80 and have 50 of them running on the same box, that this is how that is possible, is because the namespaces provide only those ports to the container itself. Now, they have to be unique when they're advertised outside of the container, but once they're inside the container, it's perfectly fine to have as many port 80s as you'd like, or 443s. PID namespace, the process ID number namespace, that isolates processes by assigning process ID numbers to each one that's executing. And so no matter how many copies of that process is running, each one has its own unique PID. PIDs are hierarchical, and every PID has a parent. The first one, they all nest from PID 1. Which, by the way, is the init process, and that is system D init in a system D system. But that is the mother of all of the process IDs in the system. Everything will fork off of that particular process. So you can follow the nest all the way back from your process ID all the way up to whatever process spawned you. It could be the shell, and then the shell process is in turn spawned by something else, and up the tree you can go. There are also a child process ID that's maintained as well. There's a parent ID, a PPID, and there's also a child ID that's maintained, but although that link doesn't show up directly, it shows up in the child itself. But that allows signals like, for example, the kill command to target just a specific instance of the process. Now, it is a prune operation, right? If I kill the parent process of several children, they get an interrupt signal that says it's been killed. Whether or not they respond to it, that's up to the programmer to decide whether they want to ignore it or just zombie themselves and run under the init process and continue until they've completed their work. But anyway, eventually the Linux kernel will come around and get them. It will collect them up and take them out of memory and return their resources. But time namespace, that provides isolation for the boot time clocks and also offset to the time spaces. So this one is a bit strange, right? So as I understand this, and I might be wrong, but the way I understand this is that this was designed to handle the problem in containers when you have the host operating system doing preemptive multitasking. Preemptive multitasking means that I can stop the container completely from running. Well, I've got a clock that's running inside the container, right? If I stop it, the clock stops with it. So this was to allow the clocks to get out of sync, and allows the container to think that nothing happened, that the preemptive scheduler didn't stop it for a period of time. So once it starts up again, the namespace continues on, and the container doesn't know that, hey, the clock stopped. But that was what I understand this was designed to solve. But it also allows the container to run their own NTP processes as well. So yeah, I mean, you're going to get into drift situations, right, when you have the preempter is stopping it. If your container is hoping for an accurate time clock, then it'll probably want to run its own NTP in order to make sure that those things don't pull it out of sync. So yeah, I mean that was why I understand this was done. So that's what it's about. So I don't have to cover that one in a future one. I just did it for you. User namespace, that traces its back to one of the beginnings. I think this was one of the second ones that was put in a couple years later. But I mean, as far as the idea of user separation within Linux, that's a core value that goes all the way back to the beginning. And the user namespace and the group is isolated to a user ID and a group ID. And those can be nested such that, and this is one of the things that is provided in the current Linux kernel. I can set up a container that's running as an unprivileged user, and yet I can have a privileged task running nested inside of that container. So, or I could even go to the extreme and have a unprivileged user starting a process that nests a process that is running under that as privileged. So this is one of those things that's kind of worrisome to me for security, but so far, I mean, it hasn't been a problem. It's just that it is a little concerning that you're allowing an unprivileged user to escalate to a root privilege status. And yeah, so anyway, I'm just going to leave that one alone. I think this one has been. They've talked about this, in the kernel space many times. So far, it's not been a problem, but that doesn't mean it won't be, right? So, watch this one, and we'll see what happens in the future. The Unix time-sharing namespace, that one comes from the Unix System 5 as well. It is kind of a strange name for this, though, in that it's meant to isolate two system identifiers from each other. So this is my node and host name, my node name or my host name, and my domain name. So basically, this allows my container to have a host and a domain name that's different from the host, which is running the container itself. And each of those containers can have their own host name and their own domain name, and they don't have to be associated at all with the network on which it's running. This is how clouds are built up for how a shareable cloud is built up is based on the UTS namespace. So yeah, it's a little bit misleading, but that was really the UTS time sharing was where that was declared. So the structure came from the UTS, and that is what is used in the Unix time sharing namespace. So, conclusions here. It's been almost 2 decades since namespaces were introduced into Linux. Now, does that mean that it's old, outmoded, and out of date? Certainly not. I mean, they are continuing to expand and build and tweak and improve these versions over time. So it's really not fair. It's really not fair for someone to make that claim that namespaces are old, out of date, and they're as good as they need to be. That's my point. They're as good as they need to be. If they need to be made better, propose something to the Linux Foundation and start writing the code. See if they'll take it. But it has evolved installed to 8 of them as of the version 5.6. So you can see, and there are more waiting to get in, but as you can see, it is evolving. It is continuing to grow. It isn't continuing to improve. So I don't agree with that comment that it's old and outdated. There are many applications that use namespaces today. Google Chrome uses it, and that's to isolate its own processes from and to reduce the risk of attack from the internet side. So, and that's just an example. I'm sure there are many, many others that use namespaces. So, anyway, I just wanted to clear up that confusion. I know it was a marketing person that said that, but anyway, it is not true. That is certainly not true. And they have been with us a very long time, but unfortunately, programs still need variables. they still need objects. Objects take memory, and memory locations have to be referenced in some way or fashion. So anyway, hope you enjoyed this talk today. Hope to see you all again real soon. Please like and subscribe, and hope to see you again in the next video. Bye for now.